Our final look at what is a disease concerns how diseases have changed over time. The diseases encountered by our ancestors are not the diseases that we encounter today. Monogenic and stochastic developmental diseases, however, are nearly independent of the environment, and so their frequency was probably the same for the Greeks, the Romans, and the Han Chinese as it is for us today. However, environmental diseases are often caused now by mismatches between biology and culture, and that's a new development. We define disease prevalence as the fraction of the population that is afflicted. We define disease incidence as the number of new cases per unit time, and both prevalence and incidence vary widely in space and time. Diseases may occur in clusters for simple reasons, including poor nutrition or medical care. In other cases, the positive or negative correlation of diseases can have biological reasons, reflecting their genetic and physiological trade-offs that are causing vulnerabilities. Monogenic and stochastic developmental diseases are important, but their incidence is independent of the environment except for mutagenic activity. So exposure to ultraviolet light, radioactivity, and chemical mutagens can alter their incidence. But if those are held constant, then these are occurring at a fairly steady background rate. The rare mutations that cause them are basically set by the rate at which DNA gets repaired and by these sort of background exposures, things like the cosmic ray incidence. Their prevalence, however, is increasing as medical care improves. That will eventually increase the frequencies in the population of some of the mutations that cause them. However, it is unlikely that they will ever become very frequent. Environmental changes are causing much bigger changes in the nature of disease. The major environmental changes in our history include our exit from Africa, which exposed us to lower temperatures and new pathogens. The agricultural revolution, which brought with it a new diet, urbanization, and diseases that we acquired from domestic animals. And the industrial revolution, which brought with it hygiene, clean water, electricity, artificial light, processed food, and pharmaceuticals in the form of antibiotics, vaccines, statins, histamine blockers, NSAIDs, and so forth. So we have recently experienced major environmental change on a number of timescales. Now, that creates mismatch, and the outcome of mismatch depends on trade-offs. Some new diseases emerge directly from novel toxins or pathogens, such as dioxin poisoning or HIV. Now, they can be eliminated by removing the toxin or, if possible, developing a vaccine. Others become more prevalent when environmental change shifts the cost-benefit relationship in a trade-off that had been optimized to a prior environment. For example, immune responses that were selected in past epidemics may increase the risk of autoimmune diseases, allergies, and asthma. Changes in the cost-benefit balance of trade-offs are also responsible for many of the diseases of homeostasis, such as type 2 diabetes and cardiovascular disease. Environmental change is also shifting our demographics with very far-reaching consequences. Modernity has brought a dramatic decline in extrinsic mortality that had previously been caused by childhood infections and starvation. The resulting extension of lifespan has exposed many age-related chronic diseases that were previously rare but are now increasingly common. These diseases include cancer, neurodegeneration, diseases of failed defenses, all of which are associated with age-related declines in maintenance programs. If these diseases are conquered, new ones will emerge as the process continues. How much average human life will be extended and how much well-being will be improved is, at this point, unclear. To summarize, the prevalence and the incidence of types of disease has been changing dramatically, especially recently. Genetic and stochastic developmental diseases are relatively unaffected by environmental change. Environmental change does cause most shifts in human disease patterns, either directly when environmental toxins or obesogenic diets or emerging pathogens encounter us, or indirectly through disruptions of trade-off equilibria. So that would elicit diseases of defenses, homeostasis, and of reduced maintenance. The overall picture is that dramatic recent environmental change is exposing vulnerabilities and trade-offs in our biology that evolution has not yet had time to fix.